In this video, we're going to create a model of a painter's point. Painter's point is actually a fairly small little object, and the idea is that when you have it sitting on the ground, you can rest something on it. So if you're painting it, if you're going to put a finish on it, something where you want to cover all of the surfaces, but you don't necessarily want to instantly put it onto a table or another flat surface. That's what a carpenter, what a woodworker would use to go ahead and help them in creating their final product. But these items can actually cost a decent amount. But as you can see, it can be something that's fairly easily and inexpensively 3D printed. But what's left is, how do you actually create that model? And when you think about it, a pyramid, triangular shape like this is fairly basic in a lot of ways. But what you're going to find is it's not necessarily going to be the easiest thing to go ahead and create in CAD software. So today we're going to be using OnShape to go ahead and look at a couple of tools. How we can use the rotational patterns, circular patterns, how we can use Boolean Logic to help us actually create this symmetrical shape, and then how we can use the shell tool to actually hollow out a more complex shape. So we'll just kind of dive in straight from there. So as usual, we go ahead and create a new document. And I'll admit I had to play around with this a little bit to figure it out. So first thing, of course, is we start with our sketches. We'll create it on the front view, rotate our view to go ahead and help us out. And then, of course, use the line tool to go ahead and sketch out the general shape. Now, I'm also going to include a construction line in the center to help us with some of our rotations a little bit later. So remember, construction lines, hit Q, or you can go ahead and just hit the tool up there. So the next step, of course, is to go ahead and do the dimensioning. So for the base, I want a base of 2 inches. I want to keep this fairly centered, so it helps to actually get the values in there. And then in terms of height, I don't really want to do the trigonometry to figure that out. So what we can do is use what we know about equilateral triangles. And in this case, we know that a dimension angle of 60 degrees will go ahead and kind of lock it in. So these are going to be equal lengths. So with this finished, we can go ahead and switch back to a home view, and then we can extrude, so Shift E, and because I'm aiming for some symmetry in here, I'm going to have it go in both directions with a total depth of 2 inches. So with that finished, that is starting to look like a pyramid of sorts, but we're looking for 4 sides to be looking exactly the same. So here's where we're going to have them basically intersect. We're going to rotate it around and then have it so only the material that overlaps with one another is going to remain part of the model. So to do that, we're going to select the extrusion. We're going to use the circular pattern to go ahead and select the whole thing as our entity to rotate. For the axis of pattern, that's where we had that hidden line, that construction line set up earlier. And then we can leave it at 360 degrees with 4 rotations. You can play around with this and notice that, if we only go for 3, it's going to change the degrees. But in this case, 360 degrees, 4 iterations is going to work just fine for us. And what we've got is actually probably a few more parts than we actually need. I'm actually going to undo that, redo the command, so select everything, 3D pattern, and just because I don't want to have 4 parts to have them intersecting with each other, we're going to go with 90 degrees, 2 iterations, Okay, that brings the part count down. Hit OK. And then the next step, this would have worked in either case, select both of these parts, okay, and then we're going to use the Boolean command. Okay, Boolean logic is a very common thing. You know, we've already seen it some where you can join them together permanently, where we could subtract one from the other, or in this case we can have the intersect. And when we select intersect, okay, we can see that this is only going to exist where they have that overlap. Okay, so that's actually going to do exactly what we want for creating that pyramid shape itself. Okay? But what that leaves us with is a fairly complex component. And because we're planning on printing these out ourselves, we want it hollow on the inside. What we're going to do is we're going to shift our view down towards the bottom of the device, okay? And then we're using what is called the shell tool. And the idea of the shell tool is it will thin out the walls, okay, by removing a face, where you can have it remove several faces, and then the material inside of it. Okay? So by telling it that we want to hollow this out, okay, well, we don't actually want to hollow it out. If we hollow it out, okay, it will basically hollow out the inside. Okay? That's not what we're looking for. Okay? In this case, we're wanting to remove the bottom and then hollow out everything inside there. Okay? And we can set the wall thickness. You know, if we want to have it as 1/4 inch, we can set it as 1/4 inch. Okay. I think that's a little thick, so I actually like leaving it at that 0.1 inches. Okay, that should be enough kind of for this item. Now, again, because we're going to 3D print our own and we want a little less material there, I'm going to put in a little kind of finishing touch, and we're going to go ahead and sketch out on the front view. We're going to put in a circle. Okay. We'll do about a 5/8 of a circle. Okay. We'll dimension that in place. And then finish the sketch to go ahead and then Shift E to extrude. We're removing through all. It's not quite what I actually want, but we can go ahead and just adjust that, because again, we can use the rotational patterns. So using that same circular pattern, we're going to tell it that we want to not do the entire part. In this case, we're just doing a feature. Okay, in this case, extrusion 2, going around that same axis that we used earlier. In this case, we do want the 4 interactions to go ahead and clear out holes on all 4 sides. So, using the rotational patterns and the Boolean tools, we were able to go ahead and create the pyramid, the painter's point shape, and then use the shell command to go ahead and hollow it out, make it a little less material, while still having the same strength to go ahead and use as a real-life application. So whether you're trying to model a historical pyramid from Egypt, or if you're trying to create a more functional painter's point for a woodworking project, you've got the tools that can help you with creating the models that you need. So as always, feel free to ask questions, some ideas of new models or tools and features that you want to learn how to use in the comments, and as always, I'm happy to help you out. So take care.